Hello, Mr. Gazda here. This is 277 solar system coloring. Okay, here we go. What you want to do is, first thing you want to do, let's do this right off the bat. Let's find your letter of your last name, copy the number next to your name as this. My last name starts with G, 20, so I'm going to write the number 20 right here. And this is and put a circle around it right next to your name. Please do that. That's a check to make sure you're actually watching the video. Okay. You probably want to detach the pages to make the coloring easier, less flipping back and forth. So we're using this page of the reference table. It is on page 15 of the reference table. If I have a real reference table and I turn right to the back, it's on the bottom, solar system data, page right before the back. There we go. So this is the chart, and it is our solar system. Please note a few. Let's just do the first one. Color in the box that contains the number for the planet with the lowest density gray. This has been done for you as an example. You're welcome. So the density numbers are here, and they're grams per cubic centimeter. And the lowest number here is Saturn. I colored it in gray. That is the density of 0.7. Lowest density. Actually, the highest density here, just by the way, is Earth, 5.5. So that's done for you. 2. Color in the box that contains the number for the planet with the highest density red. Oh, that's the next one. I forgot that was the next one. So I'm going to get some red here, if I can find a red pencil. And the highest density is this right here. So I'm coloring the number. What that means is that Earth is the highest density. 5.5 is our average density of Earth. Okay. And that's that. So number 3. Okay, first of all, let's do about elliptical is the shapes of orbits. It's how elliptical it is. The more elliptical an orbit is, it's flatter of an oval, less like a circle. The eccentricity number is closer to 1. Eccentricity measures how oval an orbit is, and 1 is the most oval. If it's less elliptical, more like a circle, it's closer like a circle, it's closer to 0. So eccentricity is always between 0.00 and 1.00. It can't be any higher than that. No units on it. Also, this is key. This is very important, and it makes it a little more challenging when you do this, is that the sun is a star, not a planet, and Earth's moon is not a planet because it's a moon. So when I say planets here, we're not including the sun and we're not including the moon. That's a little tricky, but don't get caught up on that. So, color in the box that contains the number for the planet with the most elliptical orbit, blue. Okay, so blue is going to be this, and the most elliptical is going to be highest number here. So I have to look here under eccentricity. What's the highest number? The highest number here. It's difficult because they're decimals. Okay, the highest would be closer to 1. That is Mercury. Okay, and I'm coloring in the box. That's what I mean by coloring in the box with a number. That is blue. Highest eccentricity. This is most like a most oval shape is Mercury, of all the planets in our solar system. 4. Color in the box that contains the number for the planet with the least elliptical orbit, green. Now I'm looking for the lowest number. This is even more difficult, I think, because these numbers get really low. What is closest to 0? You got to really look through 0.007. That's low. This is even higher than that, so that's the lowest. And then these are low. That's also low, but not as low as that. Therefore, the lowest or the closest to a circle is Venus. And 0.007, that is, oh man, that is very, very close to being circular. You could not tell from looking at it that it was not actually a perfect circle. Next up is 5. Color in the box that contains the number for the planet with the longest day, purple. Hint, it's the one with the longest period of rotation. Period of rotation means how long it takes to rotate once. Okay, so the longest time, what takes the longest time to go around? D is days, Y is years. If you look here, the sun doesn't count, 59 days, 243 days. These are now in hours. These are all in hours. So the best answer, and I'm coloring it purple, let me get purple, is this. Venus takes 243 Earth days to rotate once. Okay, and Earth right here, that's 1 day. That's our 24 hours basically. That's purple for number 5. This is 6 right here. It got cut off. And it is color in the box that contains the number for the planet with the shortest year, brown, period of revolution. Period of revolution means how long it takes to revolve once around the sun. So, what am I doing? Longest time, I think. Oh, no, I'm sorry. Shortest year, brown. Okay, so I look here. Now, these are in years and these are in days. So, the shortest time frame is going to be Mercury, and I'm coloring that in brown right here. 88 days. They look at the order. 88. They vary in the pattern here is very much getting longer, and that's how it works. The closer to the sun is a shorter period of revolution, a shorter year, and it gets longer as you go out. Look, Neptune takes basically 165 years to go around the sun once, and Earth again. This is our 1 year. So that's brown, 88 days here. This is just getting you to use this reference table. Not super exciting, but color in the box that contains the number for the planet with the second most elliptical orbit, orange. Orange, yeah. So second elliptical, eccentricity, I want the highest number. Now this is the highest. What's the next highest here? I have to really look as to what. Oh, that's 0.09. That's pretty high. Is anything else as high as that? So you really got to think. These really, you got to think of like, mental number line, but they're decimals, so it's tricky. But the answer is this. Mars should be orange. That's the second most elliptical. That's the second most. What else do we have here? 8, color in the box that contains the number for the largest planet, yellow. And here we're doing this by size, so use diameter. Largest diameter, and we're doing yellow here. Let me grab my yellow pencil. So I want diameter. Where's diameter? You get rid of that pencil. Diameter is here. Now I don't want to do the sun because the sun is not a planet, and I don't want to do the moon. The largest diameter at the equator is Jupiter, and this is in kilometers. But if you look compared to Earth, Earth is 12,000. This is 142,000. So it's 12 times bigger diameter, which is just. Is huge. It even looks bigger than 12 times if you were to see it. Let me see. 9, color in the box that contains the number for the smallest planet, red, and we're using diameter again, and I got to get some red. So now we want the smallest diameter here, and you're going to see it is Mercury, not the moon, because the moon's not a planet, so don't fall into that trap or get tricked by that. It's not a trap, it's a little confusing. So always think about what you're doing. Don't just randomly go through the numbers without some thought. Draw on the graphs below. If necessary, write no relationship. So distance from the sun, and this is all distance from the sun. So this is the sun. This is closest to furthest out. That's how they have it. That's the order that this is in, and you can kind of tell from here. And we're going to do length of the year on the planet, distance from the sun. So as you get further out from the sun, the length of the year goes from 88 days to 224 days to 365 to 687. Then we're at 12 years basically. So as you go out, it goes up. So that is clearly, the relationship clearly is a positive one. Close to the sun, always want to check. Close to the sun, shorter length of the year. Further from the sun, longer length of the year. That works. And then we're going to do distance from the sun, length of the day. Length of the day, so how it rotates on its axis. So this is what we're doing, period of rotation. You want to use period of rotation. So Mercury's 59 days, and then it jumps up to 243 days. So Venus rotates very slowly. And then you do 23, 24, 9, 10, 17, 16. So this is really, it jumps up to here, and then it these are close to the same, and then it goes down, and then it goes up. This is definitely shorter. They spin faster out here for sure, and then this is kind of longer. But I think that maybe the best answer is there's no relationship, or the relationship is weak. That's probably the best answer. What I have on my answer key, which also kind of works, is something like this. Now I don't really expect this, but if you wrote that, something like that, that's good too. But really, there's not a clear relationship, not like we usually see in science. So that is a bit challenging of a question. And then the last one is this one here: distance from the sun, eccentricity of orbit. Is there a relationship? Does distance from the sun affect the eccentricity? So this is 0.206, and this is the highest one, the lowest one, And if you see the numbers just really jump around, this is really low here, second lowest number. This is no real order at all. So this is definitely, there's no relationship here. And that throws people for a loop because they're used to seeing some relationships in homeworks and science, but those are the answers, so don't get tricked by those. How many times larger is the Sun than Earth by mass? The Sun. How much bigger is the Sun than Earth by mass? Oh, see, look at this. What they did is they didn't give the actual weight in pounds or kilograms because that would be crazy. What they did is, let's make Earth 1 and everything compare it to Earth. So if Earth is 1, the Sun mass, how much mass it has, the weight basically to simplify, it is look at that, it's 333,000 times more mass than Earth, which is really hard to think about, hard to wrap your brain around, but that is the answer, which is really crazy. And then this one, this is about, the Earth is about how many times larger by diameter than the Moon, and the choices are 1.5 times, 2 times, 4 times, 6 times, 10 times, 20 times, 100 times. By diameter here. So I'm going to look at diameter. This is the Moon, and this is Earth. So if I just look on a basic level, I just look 12 divided by 3, it's about 4. Okay? That was my point here. But if you are really into it, and you know, this is a good way to do it, have your calculator out. Divide that by that, 3, 4, 7, 6. It's 3.7 or 3.67, whatever it is. Now, of our choices here, the best answer is 4 times. So the diameter of Earth is 4 times that of the Moon, or about a little bit less, which is another good thing to think about when you're looking at the Moon. Hopefully you did okay with that. There's no questions on the back. All right. I am Mr. Gazda, and I approve of this homework.